Hello friend, welcome back to our new video. Today we discuss on the topic of projectile motion. The motion of object soaring through the air has been a source of fascination for scientists and curious individuals throughout history. In physics, projectile motion is a fundamental concept that unravels the captivating nature of objects propelled into the air, guided solely by the force of gravity. This article explores projectile motion, unraveling its core principles, delving into its mathematical formulations, and shedding light on its practical application in the real world. Table of contents. What is projectile? What is projectile motion? Parabolic motion of projectiles. Total time of flight. Horizontal range. Maximum height of projectile. The equation of trajectory. Basketball physics. Solve example. Frequently asked question. What is projectile? A projectile is any object thrown into space upon which the only acting force is gravity. The primary force acting on a projectile is gravity. This does not necessarily mean that other forces do not act on it, just that their effect is minimal compared to gravity. The path followed by a projectile is known as trajectory. A basketball batted or thrown is an example of projectile. What is projectile motion? When a projectile is thrown obliquely near the Earth's surface, it moves along a curved path under constant acceleration directed toward the center of Earth. We assume that the particle remains close to the Earth's surface. The path of such a particle is called projectile and its motion is called projectile motion. In a projectile motion, there are two simultaneous independent rectilinear motions. First, along the x-axis, a uniform velocity responsible for the horizontal forward motion. Point 2 along the y-axis, uniform acceleration responsible for the vertical downward motion of the particle. Acceleration is the horizontal projectile motion and vertical projectile motion of a particle. When a particle is projected in the air with some speed, the only force acting on it during its time in the air is the acceleration due to gravity. This acceleration acts vertically downward. There is no acceleration in the horizontal direction, which means that the velocity of particle in the horizontal direction remains constant. Parabolic motion of projectiles. Let us consider a ball projected at an angle theta with respect to the horizontal x-axis with the initial velocity u as shown below. The point O is called point of projection. Theta is the angle of projection and OB equal to horizontal range or simply range. The total time taken by the particle from reaching O to B is called time of flight. For finding different parameters related to projectile motion, we can make use of differential equation of motion. V is equal to initial velocity, g is equal to acceleration due to gravity, t is equal to time, s is equal to displacement, v is equal to final velocity. Total time of flight resulted displacement is equal to 0 in a vertical direction. Therefore, the time of flight formula is given by using the equation of motion. Gt is equal to 2 into uyt minus sy. Here, uy is equal to u sine theta and sy is equal to 0. For example, G2 is equal to 2t cross u sine theta. Therefore, the time of flight formula t is given by total time of flight t is equal to 2 usi over g. Horizontal range. Horizontal range is equal to horizontal component of velocity cross total time flight. R is equal to u cos theta cross multiplication 2 u sine theta g. Therefore, is a projectile motion, the horizontal range is given by horizontal range is equal to u square sine 2 over q. Maximum height of projectiles. After understanding what a projectile is, let us know the maximum height of projectile. The object's maximum height is the highest vertical position along its trajectory. The horizontal displacement of the projectile is called range of the projectile. The range of projectile is depend on the object's initial velocity. If v is the initial velocity, g is equal to acceleration due to the gravity, and h is equal to maximum height in meter. Theta is equal to angle of initial velocity from the horizontal plane, radians or degrees. The maximum height of the projectile is given by the formula h is equal to u square theta sine square theta over 2g. The equation of trajectory. Equation of trajectory. This is the equation of trajectory projectile motion extend, and it's proved that projectile motion is always parabolic in nature. Basketball physics. We know that projectile motion is a type of two-dimensional motion or motion in a plane. It is assumed that the only force acting on a projectile, the object experiencing projectile motion, is the force due to gravity. But how can we define projectile motion in the real world? How are the concept of projectile motion applicable to daily life? Let us to see some real-life example of projectile motion in two dimensions. All of us know about basketball. The player jumps a little to score basket and throw the ball in basket. The motion of the ball is in the form of projectile. Hence, it is referred to as projectile motion. What advantage does jumping give to their chances of scoring a basket? Now, apart from basketball, if we throw a cricket ball, a stone in a river, a javelin throw, an angry bird, a football, or a bullet. All these motions have one thing in common. They all show a projectile motion, and that is the moment they are released. There is only one force acting on them: gravity. It pulls them downwards, thus giving all of them an equal impartial acceleration. It implies that if something is being thrown in the air, it can easily be predicted how long the projectile will be in the air and at what distance it will hit the ground from the initial point. If the air resistance is neglected, there should be no acceleration in the horizontal acceleration direction. This implies that as long as a body is thrown near the surface, the body motion can be considered a two-dimensional motion with acceleration only in one direction. But how can be concluded that a body thrown in the air follows a two-dimensional path? To understand that, it lets us assume a ball that is rolling, as shown below. Figure 1 motion in one direct dimension. Now, if the ball is rolled along the path shown, what can we say about the dimensional of motion? The most common answer would be that it has x component and a y component. It is moving to a plane, so it must be example of motion in two-dimensional, but it is not correct. As it can be noticed that there exists a line that can completely define the basketball's motion, thus it can be an example of motion in one dimension. Therefore, the choice of axis does not alter the nature of the motion itself. Thanks for watching our complete video. We will meet in the next video. So don't forget to subscribe and press on bell icon for more our interesting and informative upcoming videos.